How might the physics project help advance technologies like fusion power? From memes. Um, I don't know. I think, let me see. Uh, there are different approaches to fusion. I mean, the one that most people are pursuing is confine a plasma uh, at very high temperature, use magnetic methods to confine the plasma, kind of squash it and get by the fact that there's such a high temperature, the all the ions, all the nuclei are whizzing around at high speed, get them to crash into each other fast enough, so to speak, that they overcome the electrical barrier and electrical repulsion barrier and are able to undergo fusion. And then once that happens, get the heat out without destroying the fusion device. I think one of the problems is that as soon as fusion is happening, there's all kinds of neutrons being produced and all sorts of other particles, and any material that is sort of generating a magnetic field, it's going to get shredded by all these random pieces of radiation going through it, and that will be it's a question of, can you sort of keep the container containing things, or will the container's crystal structure be totally broken down and so on? It's actually a possibility to do it in space, where you could imagine having having some kind of liquid thing as the enclosure for uh, for the um, uh, um, for the fusion reactor. And if it's a liquid, you can obviously cycle it out and get and sort of take the heat that's being generated from the fusion reaction, take it out, use it, and also a liquid is not as persnickety about its crystal structure because it doesn't have a crystal structure. And so long as you're maintaining it as being all mercury or whatever, and you're filtering out things that are no longer mercury because they underwent nuclear reactions and nuclear transmutations, then you have a good thing going. And maybe that's easier to do in space where there's microgravity than it is on Earth. Of course, if you say, well, let's put a fusion reactor really far away and let's get the energy from that fusion reactor and bring it down here on Earth. Well, actually, we have one of those. It's really big. It's 93 million miles away, and it's the sun. So at some point, it becomes a bit silly to say, put those fusion reactors far away and have them generate, for example, electromagnetic radiation or light or heat or whatever, and then we pick it up here on Earth, because we might as well just do that from the sun. So I'm not sure how that plays out. But, I have long suspected that, cold fusion, which became one of these things where it's sort of experiments were done, people reported things, people said those experiments weren't right, et cetera, et cetera, et cetera. But the basic idea that you can take a material, in that case it was palladium, and have that material just absorb so many hydrogen ions, so many protons, that eventually their density becomes high enough that that they can undergo fusion. I don't think that's a totally crazy idea. The fact that, and there's a consistent undercurrent of serious people reporting results along those lines. Now, the fact is, it's very easy to get some fusion to happen. Lots of things, in all kinds of situations, just with simple, like tiny particle accelerators, just accelerate, desktop-sized particle accelerators. You can get some fusion to happen, but if it's just a few nuclei, it doesn't really do much for you. So, a question which was asked is, does our physics project reveal anything interesting about that? And that's a good question. I think the most likely vector for success, I would think, would be not something like, oh, it's a new piece of physics, but more, it's a better understanding of some existing piece of physics. My tendency would be to say that the thinking about various kinds of metamaterials, materials which don't have just I'm going to have a crystal structure that's arranged very regularly and grown in a particular way, but have a more complicated computational structure, something that we've sort of come out of things about exploring the computational universe, the possibility of deterministic random crystals, for example, where there's only one way the atoms can arrange, but it's not a regular way. Things like that might be relevant to more sort of on the cold fusion end, of how you achieve fusion. So my feeling is that the thing most likely to be relevant is issues of formalism and things where, oh, I never imagined there could be a material like that. But now, as you think about it in the appropriate kind of computation all the way down type way, you realize, well, actually, there is this way that that could potentially be achieved. My first thoughts on that. Interesting question. Good question. I really haven't thought about it. So, and that's why I like doing these live streams. You guys get me to think about all kinds of things I don't usually think about, and certainly don't try and verbalize as I try to do here.